This should be short and sweet. Circumference and arc length. So we already know circumference. What formulas come to mind when I say circumference? Two pi r and pi d. Very good. Perfect. So this is old news. Circumference is 2 pi r, or also known as pi d. And we're going to skip the clip and come back to it. I'm sorry if we have time. All right, so this is a very important slide, so I need your attention right here because students get confused with this sometimes. In a circle, when we talk about an arc, remember there's a minor arc, there's a major arc, and there's a semicircle. Anyways, when we talk about arcs, arcs can have a length and they can have a measure. So when I'm talking about a length, arc length, I'm talking about the distance from A to B. When I'm talking about the length, I'm talking about the distance from A to B. So like if I were an ant and I started at A and I walked along the circle to B, how far would I walk? That would be like measured in centimeters. That's arc length. It's a distance. An arc is also going to have a measure, just like you're a person and you have a height, but you also have a weight. And those are two totally different measurements, and they're not always dependent on one another, right? But in the circle, they will be connected totally. But anyways, you have a height and you have a weight. An arc has a length and it has a measure. The measure is going to be a degree measure, like a degree, some number out of 360, because that's the total degrees in a circle, okay? So an arc has a length and a measure. A length and a degree measure. I think I pounded that one in good enough. All right, so let's talk about arc length. Now, to confuse you even further, the mathematicians decided to use a cursive L to represent arc length. Wait a minute, we've already used that before. That was slant height. So you're going to have to erase that from your mind, kind of like tangent with trig. Erase slant height from your mind. Cursive L now means arc length. So I did not make that up. Sorry about that. Cursive L means arc length. How far is it from here to here? How far? So let's find out how we're going to decide how far it is from A to B. So let's see if we can kind of come up with this on our own so that you see where the formula comes from. So take angle M. What's the measure of angle M? Oh, Mean Jung, don't give it away. What's the measure of angle M, guys? 180, absolutely. How does 180 compare to 360? It's half. What's the circumference of that circle? If you went all the way around the circle, how far would you go? Well, if 180 is half of 360, if I want to know how far it is halfway across the circle, wouldn't I just take the circumference and cut it in half? 8 pi cut in half. So the length of this arc, the length of arc AB, would be 4 pi. Let's try another one because that one was too easy because it was just half. Let's try another one. What's the measure of angle M? That's wonderful that you learned this in 4th grade. 90. How does 90 compare to 360? It's 1/4 of 360. So don't you just agree that I could find the circumference and I could just take 1/4 of the circumference? The circumference is still 8 pi. So how long is this arc? How long? It's 8 pi divided by 4. It's 1/4 of all the way around the circle. It's 1/4. So what are we going to be doing each time? We're going to compare the angle to 360, and that's going to be directly related to the arc length to the circumference. I think we get the idea. We're going to skip that one. So here is what you need to write down in your notes. This is not on your formula chart. So this is something that you do need to commit to memory. L over C equals M over 360. That's just saying the arc length is to all the way around as the angle is to all the way around. The length of the arc is to the circumference as the angle measure is to 360. This proportion, this formula does have one constant, and the constant's 360. That's never going to change. There is another way to put this formula. And if you like that way better, you're welcome to use that way. I'm going to use the first way. So when I'm teaching it in the notes, I'm going to use the first way. But if this way makes more sense to you, this is saying circumference times whatever the angle is over 360. It's the same exact formula, and now it's just the formula solved for arc length. It's the same thing though. Circumference times the angle over 360. So that's up to you if you like doing cross multiplying, or if you like to memorize this formula right here. That's up to you. Alright, so let's try some. So here we go. We've got a 30-degree angle, and we've got a radius of 12. So let's start by finding the circumference. How far would we travel if we went all the way around? (24 pi meters, right? We're going to keep it in terms of pi unless someone tells us otherwise. So now the length of AB, we don't know it yet, but we're going to compare the length to all the way around as 30 is to all the way around. So it's kind of like part is to total as part is to total. Does that make sense? So you put your totals on the bottom and you put your parts on the top. Okay. 24 times 30 divided by 360. What is the arc length, guys and gals? What is the arc length? Do not press the pi button. 24 times 30 divided by 360. Yay, Albert, thank you. So the length of AB is 2 pi meters. What questions can I answer? Because it seems like that did not sink in. Let's see if we can just go straight to another one, and then I'll come back to that one if we need to. Okay, so this time they gave us L, and we want to find M. So here's the proportion. Here's the proportion. Let's plug in what we know. We already know L, it's 3 pi. We can find C, just double 6. We don't know M, and 360 is constant. The pi's will cancel, so now you're going to cross multiply again. Every time you're going to cross multiply. 3 times 360 divided by 12. So believe it or not, whether it looks like it or not, that is a 90-degree angle. Because 3 is a fourth of 12, and 90 is a fourth of 360. So hopefully you're kind of seeing how this is all related. All right, let's try this one. So we know L, we don't know C, we know M, and 360 is constant. So we can cross multiply 2.5 times 360 divided by 150. And we get But we need to be careful. When we cross multiplied, we found C. We didn't find R. So we know to go from circumference to radius, we just divide by 2 pi, because that's what the formula says, 2 pi r. The pi's will cancel, and 6 divided by 2 gives us 3. Be careful. A radius is not curved. Anything curved gets the pi symbol. But a radius is not curved, so you would never put the pi symbol on a radius. So today is all about proportions. Find the length of the pink arc. So this is the pink arc. It goes from here to here. So we've got two options. We don't really work with angles bigger than 180 in this class, but we can figure out that angle. It's called a reflex angle, but we can figure it out, right? What is that angle? The angle that intercepts that arc. So quite a big angle. Sorry. The radius is 18. We don't need the radius, right? There we go. So I'm not going to put 30 over 360 because if I use 30, then I'm going to be finding that green arc right there. But that's not the arc I'm looking for. So instead of putting 30, what would I put for my M, for my measure? There you go, okay? So be careful. We're looking for that major arc. It's a major arc. And so our angle is going to be much greater than 180. It's going to be greater than a straight angle. So now we can cross multiply. 36 times 330 divided by 360. And we get, what do we get? Yes, Adriana, it's just 360 minus 30. Yes, it is. What do we get? Yes. Almost. Final answer. So the only tricky part here was that M, the measure, was not specifically on our picture. We had to subtract 30 from 360 to get M. 33 pi inches. Remember, anything that's curved needs a pi in the answer. An arc length is curved, so it needs pi in its answer. A car has a turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much farther does a tire travel on the outside than on the inside? So how much more wear and tear does the outside tire get than the inside if you're doing wheelies? Which I've never done before. So go ahead and tell me what you get. So do you want to talk strategy here? I would just find the circumference of each one, and subtract it. So circumference of the outer minus the circumference of the inner. So we're talking, we'd have to specify that we're just doing one rotation. In one rotation, how much further does it travel? So the radius of the outer one is 16.1. And the radius of the inner one, we have to do 16.1 minus 4.7. So we can find out the radius of the inner one. 11.4. So we're just finding circumference twice and subtracting. Very good. So 9.4 pi is the exact answer, And the approximate answer I got, well, we can just type it in, 9.4 times pi. Yep, that's what I got. 29.5. So depending on what the question asks, if it wants an exact answer or rounded like a real world answer. Very good. Adriana. All right, the minute hand of Boston's Custom House Tower is 13 feet long. That's a huge minute hand. In 5 minutes, how far does the tip of the minute hand travel? So in 5 minutes, how far does it travel? So a minute hand travels from here to here in 5 minutes. So I know we're going to use our new formula. Well, it's one way to go about it. L is what we're looking for. L is the length of the arc. How far does it travel? So what's the circumference? And what's the measure of that angle? What's the measure of that angle? Let's see. Well, it's 360 divided evenly into 12 numbers. So that angle would be a 30-degree angle. Are we okay with those numbers? So we would do 26 times 30 divided by 360. So you could get your answer as a fraction. It would be 13/6 pi. And once again, if we wanted to make it a real world problem and have an actual answer, it would be, they're both actual answers, but you know what I mean, an answer that makes sense to us. It moves the height of a really tall person in 5 minutes. It moves 6.8 feet in 5 minutes. So every 5 minutes, the tip of the hand moves almost 7 feet. Cool, huh? This was pretty important too, but I think I already talked about these. The measure of a circle is 360. The measure of a semicircle is 180. And the measure of a central, I did talk about this already, a central angle is equal to the measure of its intercepted arc. So if this is an 82-degree angle, then that arc is an 82-degree arc. It's not the length of the arc, it's just the measure of the arc.